I'm Adolfo Delorenzo from Portainer. I'm a sales manager engineer, and I'm more of a straight to the demo type of guy. I don't usually use PowerPoint much, so let me just bring up my screen and start presenting right away our amazing integration between Portainer and Civo. So for those who haven't yet had the chance to know what Portainer is a container platform management tool, meaning Portainer was developed to manage containerized applications, basically. What don't we do? We do not manage infrastructure, meaning we do not spin up from bare metal, and this is important, from bare metal Kubernetes clusters. We do, though, now have an amazing integration that allows us to spin up containers using CAS. And today I'm going to show you how to do that with Civo, how to set up your environment to start using Civo to spin up a Kubernetes cluster directly from Portainer, and how to manage these Kubernetes clusters within Portainer. Right, so I already have one here that I set up just for the sake of time, but I will show you how to do it step by step. So the first thing you want to do, if you have Portainer already installed, if you do not, please do deploy Portainer. It's for those who would like to know, it's very easy, portainer.io. And also we have a freemium version of Portainer that gives you full access to the business edition that is required to use the CAS functionality, which allows you to have 5 nodes free. So with this, you can spin up a 5 nodes cluster. So you just go into Portainer, download your 5 nodes license, install the Portainer business edition, and then, as some people like to say, Bob is your uncle. Now you can start using Portainer to deploy Kubernetes clusters. But specifically today, we're going to concentrate on the amazing capabilities of the Civo Kubernetes cluster. And here I already have a Civo Cloud deployed. Basically, what you need to do is once you have your Civo account, you go under your settings, profile, security, get your token, just this token here, back to Portainer, and add these credentials to your Civo account. Doing that, I'm going to delete this. I'm going to do it from scratch. So you can see I'm going to delete this provider here. Delete this one also, and start from scratch. There we go. As you can see, we support several cloud providers, but today Civo is our star. So it's basically giving the credential a name, adding your API token, and there you go. Now I am ready to start spinning up Kubernetes clusters from Portainer using the Civo Cloud infrastructure. So let's start. Any questions? Let me just make sure everybody understood that. No? Easy, right? Good. Cool. So now let's add a Civo Kubernetes cluster. Lovely. All I have to do is go into environments, add an environment, go to CAS. The first one is obviously Civo already. It's already got my credentials. It's going to connect to the Civo platform. I'm going to give this Portainer 2, because I already have Portainer 1. And here I have all the requirements to spin up a Kubernetes cluster very quickly with Civo. I can select the region, the type of node, and here we have all the possibilities that Civo provides in terms of nodes, node sizes, or better said, for your Kubernetes cluster. I'm going to select a small one for now. the amount of nodes that I want, the network. I actually created a separate network. Let me reload the cluster details here. I created a specific network called Portainer. It should show up here. Let's see. Did I or didn't I? Manage networks. Yes, I have a Portainer network. Let me just refresh that. Maybe it's the location. Oh, we can always use default for now. You can select the Kubernetes version and provision your environment. It's that easy. It's that easy. It has, I mean, it's a matter of seconds to deploy a cluster using Civo. Within the Civo interface, it's also extremely fast. I mean, the advantage here is that I'm already connected to the Civo cloud, and I will be able to connect to this cluster directly. Here I'm provisioning the Portainer cluster. As you can see, it's creating the CAS cluster. If I go into my Civo account, I will see under my Kubernetes, the same cluster being provisioned. Very soon it'll show up here. Just give it some time. And very soon we're going to see the second Portainer cluster being provisioned. This is the first one that I have already created. As you can see, these are the nodes.
Can you check in which region you created? Because that is the London one that you are seeing.
Oh, that's right. Sorry, I was looking for the, created the first one in Frankfurt, I think. Yep. Let's go to Frankfurt. There you go. Portainer 2 is here, being deployed. Lovely. So Portainer 1 was in London, right? Or New York?
London.
Yes.
Yeah.
London.
Maybe the network also will come in the London one.
Perfect. Right. So here Portainer 1 was already deployed. Here you see the nodes. If I go into this Portainer 1 cluster, which I am in already here, as you can see, if I go to cluster, I will see those same nodes. There you go. Exactly the same nodes, those same 3 nodes. Right. So it's that easy. Create your Civo account. If you add your credit card information, you get some credits for you to test and play around with Civo. It's an amazing platform. What I really like about the Civo platform is it's how straightforward and how easy it is to set up in environments, compute nodes. It's extremely fast and easy, and it performs very, very well. And our integration makes it even easier to use because now you can connect to your Kubernetes cluster directly within Portainer. So what's going to happen with this cluster once it's finished deploying is it's going to show up in this list of clusters right here, as this one, as you can see, is already running. Okay, any questions for now? Because now I'm going to start showing how to use Portainer on the Civo Kubernetes cluster. Lovely. Now, in terms of management, what do we do? Again, Portainer is not an infrastructure management tool for Kubernetes. It's a container management tool for Kubernetes and other orchestration platforms like Docker, like Nomad, and even Podman. But what we do in terms of infrastructure is touch what is basic for the deployment of containers. And that is, in our view, networking, so you can activate external load balancers, ingress controllers. I haven't deployed Nginx yet on this cluster, but if I can pre-provision it if I want. I'll show you in a minute what change a window means. I can restrict access to the default namespace for standard users, and you will see that in a minute what this is, but it's an important security feature. I can remove the overcommit capabilities of Kubernetes and restrict the amount of resources I want to enable to this Kubernetes cluster, meaning I have ensured 20% of resources to this Kubernetes, now only cluster, and only 80% is available for any type of deployment. This is interesting to make sure that your Kubernetes cluster can run smoothly in a healthy manner in case an application or a pod goes rogue and starts using up all your resources. You'll have 20% ensured, or whatever number you want to give it. It can be 50%, it can be 10%, I mean, whatever you want. Then connecting to the metrics, the API, the metrics server, I deployed it manually, and I'll show you how I did that because it's also an interesting feature of Portainer. And a basic management of your storage attached to your Kubernetes cluster. In this case, I'm using the default Civo volume to manage and deploy applications that need persistence onto my Kubernetes cluster. With that said, any questions? As you can see, this is basic to the management of containers. I'm not really doing more in-depth management of the infrastructure. I'm basically doing what is required to run containers in a healthy manner. No questions? Okay, great. I can also attach registries to this cluster. Basically, this goes across not only just this cluster, but any other orchestration platform that Portainer is managing, meaning other Kubernetes clusters, Docker, Docker Swarm. But here, the interesting thing about this is that I can add all these technologies in terms of registry engines and even a custom one if I have one. In this case, I have this, for instance, registry OE74.net, which not only I can attach to Portainer, but also I can manage volumes and images in here. Sorry, images in here, and I can go ahead, retag them, add new versions, delete these images. So this is quite interesting. And you will see why this is important also very, very soon. So in terms of cluster management, this is what we have. And now I'm going to go into deploying applications on the Civo Kubernetes cluster with Portainer. I see there's a question. Let's see, what is that? Okay, what is the difference between infrastructure management and container management? Does infrastructure cluster as yes, exactly. That's exactly as you saw it, Ayush. I hope I pronounced your name properly, Ayush. Yes, so Lens, you can do, as an example that Cyan showed, you can do more in-depth infrastructure management of your Kubernetes cluster. With Portainer, you cannot do that. You just touch what is necessary to do container management. And I'll show you now when I deploy a container or an application, what does that mean? Thank you for your question. Lovely. Now, there's another question. Hey, Adolfo, I want to ask how Portainer is useful when it comes to container management. Any key features? You're going to see this right now, my friend. So now what do we usually want to do in terms of application or pod deployment with Kubernetes? You want to make sure you have your namespaces defined to be able to deploy applications. You do not want to use the default one unless you know what you're doing, because the default namespace cannot be restricted and you cannot put guardrails, you cannot, it's basically open and it will use whatever resources you have available in your Kubernetes cluster. So if you want to deploy, let's say, anything in Portainer, you want to make sure you organize your deployments in namespaces. So I'm going to create one called Portainer 1, for instance. And with Portainer, the interesting thing here is I can limit resources into this cluster. I can define for this namespace resource limits, load balancer quotas, registries. For instance, this one, I can enable storage quotas. So I want to make sure that this namespace doesn't use more than 30 gigabytes. What else do I need to do here? I think that's pretty much it. Oh, I have to set at least one limit for this. I'll leave it unlimited for now and create the namespace. You notice that I didn't allow load balancers, and you would ask, but why? There's a reason why we have quota for load balancers also, because load balancers have a cost. So you want to make sure with your cloud provider that you know how much it costs to have load balancers enabled in your Kubernetes cluster. In this case, I'm going to enable 2 load balancers. Because if you just leave them open, next thing you know, you might have a high bill of because of the amount of load balancers you used. For the cloud provider, it also is a matter of cost, so it has to be charged. It's actually makes total sense that cloud providers like Civo need to charge for load balancers. So you want to make sure you manage these properly. In this case, I'm allowing 2 for this namespace. I am updating the namespace here. Now, I hope you noticed something. I did not write one single line of YAML code. Everything was done using the UI. And I updated the same namespace here with load balancers, again, using the UI. So this is what is nice and lovely about Portainer. And this is one of the main features of Portainer. Reduce the amount of coding you need to set up your environment and to bring up applications. Right, so I have a namespace here. Now any questions? Oh, I pronounced your name correctly, Ayush, thank you very much. Now, what are we going to do is deploy an application using the same form technology that we have in Portainer on the Civo Kubernetes cluster. So I'm going to open the form. And as you can see, once more, following the philosophy of making the deployment as fast and easy as possible, I'm going to deploy Nginx for now. And here, I have everything that I need to deploy this application. And I have actually some extra, one little extra feature that is more for those who use Docker, the ability to use stacks in Kubernetes. This is not something native to Kubernetes, but we can manage stacks for Kubernetes within Portainer. So you can have the stack, let's say, philosophy within Kubernetes. You can add environment variables here, as many as you need. Configurations that you want to attach if you've created configurations, or if you've created secrets. Persistence, in this case, I'm not going to use any persistence, but if you use persistence, it can be in a stateful set or deployment, however you want. If you want to reduce the amount of resources within this namespace, within the application, you can do it here. In this case, I'll leave it unlimited. And if you want to use a replicated deployment or a global deployment, it's a daemon set, meaning this is going to run in all the nodes. Maybe I could use a daemon set. And Portainer is going to let you know if by some chance something can go wrong, given the amount of resources that you have in your namespace. And how I'm going to publish this. In this case, I'm going to use a load balancer. I have 2 available. I'll create the service. I'm going to use it on port 80 on the container and port 89 on the service port. And the load balancer is going to connect on port 89. And here I have a summary of what's going to happen. As you saw, it didn't take me more than minutes, even, and with practice seconds. Oh, sorry, I forgot to talk about auto scaling. If you have the metric server enabled on Kubernetes, you can use the auto scaling features of Kubernetes, but you have to have metric server deployed. and placement rules. So if you have specific placement rules based on tags, be that architecture, be that on a specific node that you want to use. Let's say you want to use, want to make sure you deploy this Kubernetes application on this specific node, and how you want to do it, if it's mandatory or preferred. And here you will have a summary of what's going to happen. So I'm ready to deploy my application. Just click on deploy, and there you go. So it's that easy. And being that Portainer is integrated with the Civo cloud, it's going to request that IP, that extra IP, and it's waiting for Civo to bring back the IP that's going to be used in this load balancer for this given application. If I go back into my, there you go, I already have it. And you see how fast that was. If I go back into my Kubernetes dashboard in Civo, you can click on it and it will show you that application that should be running here. It's installed applications. Here you go. Oh, sorry. Oh, this is the applications I installed from the marketplace. I'm sorry, my mistake. But here on the cluster information, you will see the, once it loads, that I have 2 load balancers now. So finally, let's test this. Let's access this Nginx instance. And there you go, up and running. So that's how easy it is to deploy applications using Portainer with Civo. Very easy, very fast. And the idea is to, especially for development or even to set up environments as a systems engineer, to make sure you have first error-free, or as much as possible error-free deployment, because the forms are made in a way that's going to reduce any errors. Writing YAML files, if you do not have practice, and even for those that do have practice, that is lengthy, it is cumbersome. If you're running or deploying large platforms, you really need a lot of time to go through all your YAML files and make sure although there are tools that help you with that, it's lengthy. With Portainer, you reduce that amount of time considerably. Some people ask, but Adolfo, you're hiding the YAML. No, you can access the YAML very easily here. This is the YAML that was written by Portainer to deploy this application. But as you can see, writing this and using Portainer, time is a huge difference here in terms of being able to do this very quickly. So I do have access to the YAML, but it takes me much less time to do it with Portainer. Finally, I'm going to show you, for now, any questions? Everything good? Nice.
There are a couple of questions.
Let's see. Oh, there you go. Sorry. Is there a way to assign an ACL to the load balancers, or will these always be inbound from anywhere? In terms of ACL for load balancers in Kubernetes with Portainer, what we do is restrict this to the namespace. So whoever has access to this namespace as a user, and I'll show you how. I'm going to add, oh, I have several users here. I'm going to add, oh, I had already created user Psi, and I'm going to assign Psi to this cluster. Let's see. Wait, sorry. Adding users require effective use. Okay, wait, hold on. Environment. Oh, by the way, as you can see, the second cluster has already been deployed. It's up and running. That's very nice. Let's manage access. So, I'm going to add psi to this first cluster as a standard user. And I'm going to also assign psi to the namespace that we created on Portainer 1. So basically, in terms of ACL or RBAC, if you may, what I just did is assign the user to a Kubernetes cluster within Portainer and assigned whatever namespace I define within that cluster to the users, right? So let me just make sure Sai, I remember his password properly. I'm going to redefine the password just to make sure I can log in because I forgot the password I had defined previously. Okay, now I'm going to log in as Sai. Now, as you can see, Sai has access to this Kubernetes cluster, to 2 actually. And here he has access to the given namespace Portainer 1. And interestingly enough, which is a feature I really like about Portainer, Sai cannot see the default namespace. He can only see the namespace that was defined to him. So this is a way, the way to restrict access to those load balancers using namespaces and the RBAC functionality of Kubernetes with Portainer. I hope that answered your question, Chris. Okay, lovely. Hey, Adolfo, can we use Portainer with Minikube? And if we don't want to use cloud providers and test Portainer? Oh yeah, definitely. You definitely can use Portainer. Portainer can run on any type of Kubernetes compliant, let's say CNCF Kubernetes compliant cluster. So another thing you could do, for instance, you can bring up a compute node on Civo, install Minikube, and run Portainer on top. Actually, Portainer is a plugin to Minikube. So if you run the plugins that run on Minikube, you will see that Portainer is one of the plugins, and you can bring up Portainer right away in that Minikube instance very easily. Let me go back into my portal here. There you go. And look at that. That Portainer 2 cluster running on Civo is here deployed. Didn't take much time. And I can, one thing that is very nice about Portainer in terms of RBAC is I define RBAC once in terms of users or teams. And I can assign with only one roster of users RBAC to any of the environments that are running here. So I can say Psi on Portainer 2 is an environment administrator. And if I go into roles, my roles browser, which is something quite unique about Portainer, and this is very hard to do with Kubernetes, right? The ability to manage RBAC is something very hard because usually today with Kubernetes, you have to do this per cluster. With Portainer, you do it only once in one single interface, and you manage all your environments directly within Portainer with one roster of users. And here I see that Sai has access to 3 Kubernetes clusters. And I see here what role he has. Portainer allows you to have 5 types of roles: environment, administrator, operator, help desk. They're similar in the sense that, especially environment administrator and help desk, they have full access to the environment, although help desk is read-only. Operator has basically, he doesn't spin up containers, but he manages resources within your Kubernetes cluster. And then you have the standard user and read-only user. They're the same. The difference is that standard user can spin up containers, and read-only user cannot, but he'll have the same view that the standard user has in a given environment. Now I'm going to show you another very interesting deployment of an application using our Git integration. So think of CI/CD, where we have the CD portion of the CI/CD methodology. We do not do CI, but we do CD. So I'm going to go into, now I'm in Portainer 2 actually. As you can see, I'm in Portainer 2. Same thing. I want to create a namespace. I want to keep things nice and tidy. Oh, but before that, I want to make sure that my cluster is properly set up, because this has just been deployed. I haven't added any extra features. I want to restrict the namespace. I do not have the metric server deployed, but I'll show you how we can do that. I'm going to allow volumes to this Kubernetes cluster. A question: what is the difference between the role standard user and environment administrator? I see the same. Okay, well, the environment administrator can do this that I'm doing here. He can go into the cluster, he can set up the cluster, he can set up registries. The standard user cannot do this. He's basically, he can only manage spinning up containers. That's basically the difference. Okay, so I'm going to save the configuration for the second cluster that we have up and running. We're going to create a namespace. Call this Portainer 2. Keep things nice and tidy. I'll give it 2 load balancers also. You know what? I'm not going to restrict any resources. And I'm going to leave the quotas, the storage quotas. So it's going to be slightly different. I created this namespace. And now I'm going to give Sai access. Did I give you access to the? Yes, I already did. So now I'm going to namespace. I'm going to give Sai access to this namespace here. I suppose I did that, didn't I? Let's see, environments, Portainer 2. So, oh, okay. Sai here is an environment administrator to this Portainer, to this Kubernetes cluster. So if I go to namespaces and I try to assign them as a user, what's going to happen is I don't need to. The reason is, and this is one of the differences, he's already an administrator. I only assign namespaces to standard users. Administrators have access to everything. So if I log in as Sai into and start working on this cluster, you will see that I don't need to manage namespaces for this given Kubernetes cluster, because here the user Sai can actually manage the cluster. So he's the admin. I don't need to really assign him namespaces. He can add namespaces. He can manage namespaces. So that's one of the other differences between the administrator and the standard user. So now let's deploy an application using Git integration. So what I'm going to do is I'm going to deploy from manifest, and I'm going to use Git. I have, let's say, MySQL here. Deploy, where's MySQL? I have this file, which is a YAML manifest. And the way we do it very nicely and very easily is that you select your namespace. You can enforce that the namespaces used are the ones defined within the YAML file. Give it a name. Oh, it's already here. Head It's deploy MySQL. And something very interesting and very nice about Portainer. And when I was saying the CD portion of the CI/CD philosophy is the ability to pull that repository, and if it detects any changes, redeploy those changes onto your pods, onto your applications. So Git becomes your single source of truth. This is very especially important for developers. They have Git as their single source of truth, and they don't need to worry anymore once you connect Portainer to that Git repository in terms of deployment. Everything is going to be deployed automatically. So this is very nice. I set it up once, and then I can continue my development on top of my YAML file, and that's it. I can also use webhooks. So if on your CI pipeline, if you want to, at the end of the CI pipeline, do the deployment using a webhook, you can also do that. This will trigger the deployment once I use this link. Finally, forced redeployment is a business feature where you can ensure you always have a clean, brand new deployment of that environment. So this is especially interesting for situations when you need to have a temporary ephemeral deployment of a container. And this will ensure that you have a forced redeployment of clean. And usually the timing won't be 5 minutes, right? Unless there's a good reason for that. But let's say 24 hours. Every 24 hours, you want to refresh that deployment. You click on forced redeployment, and on the following day, it's going to come up clean. So, which I'm not going to set because it's not the case here. So again, very easy. I give the namespace, give it a name, point to the repository, the branch, the manifest. I can add files if I want to that are dependent on this deployment. Authentication if it's a private repo, and deploy. Click on deploy, and fingers crossed, there you go. Manifest successfully deployed. So this is another method of deploying applications using Portainer onto your Kubernetes clusters. If you want to see how this deployment is going, you can click on the application name, and you can click on events. There is enough memory. I can go to namespaces and click on the namespace also and see whatever events are running on that namespace. Similar to the kubectl get events namespace. Says it doesn't have enough memory. Let me see if I can add more memory, or if I restricted that. That namespace, I believe I didn't. No, I did not. Eventually, at some point, it will deploy the MySQL database. Memory reservation, 1 GB. Oh, how much memory do I have in this cluster? Maybe I don't have enough memory. You know what? Here's what we can do. We can go in here and say that the memory reservation is going to be of 112 megabytes, or I don't know, 720, or 724, and commit changes. So what's going to happen now is that Portainers are in the interval of 5 minutes is going to detect that change and try to redeploy that application. So I don't need to touch anymore the configuration of Portainer. It's going to do that automatically. Two more things I want to show you that are quite interesting about Portainer and Kubernetes. Let's say you're like, oh, I like this GUI, it's nice, but you know what? I really have to do something with kubectl. I really have to go into my cluster. I have to manage the cluster somehow. So let's say here I'm on Portainer 2. We have a kubectl shell. And in the kubectl shell, I can access the Kubernetes cluster, and I can run kubectl or Helm directly within Portainer. There you go. Kubectl get events and Portainer 2, for instance. There you go. I see what's going on with my all the events running on that namespace. The other thing, I can also run Helm if I want to deploy Helm directly from here. The other thing that we can do is export the kubeconfig. And I'm going to export, let's say, Portainer 1. And I can put it under documents. And the interesting thing about this kubeconfig, you will see, let me move this documents slide to my cube folder. Now I'm going to open, for instance, Lens. Portainer now is going to act as a Kube API proxy server for that Kubernetes cluster. The interesting thing about that is that with those two features, and those are the kubectl shell and the Kube API proxy server exporting the kubeconfig file, I do not need to expose any of those ports. The Kube API server port, I can close it, and I can close access via any type of shell, secure shell, SSH, hardware to those nodes. So this is very interesting for air-gapped, airtight Kubernetes clusters where you can have just Portainer managing them, and you don't need to expose other than the port that's going to talk to the agent on that Kubernetes cluster. And the agents that talk to the Kubernetes cluster use TLS. So it's basically a VPN between Portainer and that Kubernetes cluster. So the file we generated should be here. Let's see. Refresh. Where is Psi? Oh, here it is, Psi. So now I can access my Portainer cluster. Using Portainer as a Kube API proxy, and it will bring the size RBAC profile definitions. It takes some time. Sometimes it takes a while, and very soon we'll be able to use access via Lens to this Kubernetes cluster. In the meantime, I want to show you also something very interesting in terms of the kubeconfig file, which is being able to restrict the amount of time that you will have to use this kubeconfig file, meaning I can give an expiry time to this kubeconfig file. So if you need to share this with an external party that needs to manage your Kubernetes cluster somehow, you can determine an amount of time for it to run. It can be daily, it can be weekly, and it's just having the management. For now, it's like that. We intend to have a custom amount of time in the future, but for now, we defined 1 day, 1 week, 1 month, 1 year, or no expiry. Let's go back to Lens. Let's see if it brought up the interface. It's a bit slow, but here I can see the nodes. I can see the namespaces, Portainer 1 and Portainer 1. Then I can manage the infrastructure of that Kubernetes cluster using Lens. Another nice trick that I also do, if you have a little bit more patience, is run. Let me open a new terminal here. And let's run this. Sorry, it's black, but let me minimize Lens so it's not black on black. And increase the font. So now I can run also kubectl from my terminal if I do the following. Go into my kube folder and do a symlink of my YAML as a config file. And then I can run kubectl commands here, where Portainer is acting as a proxy server. Now look what happened. I tried running everything and it didn't work. Why? Because the user Sai does not have admin rights. He can only run kubectl on whatever he has access to. So I can do get pod on n Portainer, and this is Portainer 1. There you go. Right, any questions? Right, when there are no questions, it says are very good or very bad. Okay, finally, one last trick is, as you can see, running the same kubeconfig file on Visual Studio for developers. So if you have the Kubernetes plugin on Visual Studio, I can access that kubeconfig and via Portainer have access to your Civo cloud without having to expose that Kubernetes cluster onto the internet.